Welcome to the channel. So now we are going to solve the problem on fixed bias circuit. The circuit analysis using KVL. So the circuit is given and we have to find IC current and VC, voltage across collector and emitter. So we can apply the KVL in this direction first. To find IB, and then we can apply KVL in this direction to find VC, and from IV we can find IC. So let's start. So this will be VCC minus, because this is like plus, this is minus, this is plus, and this is minus. So voltage across these two terminals, that is base and emitter, is VBE. So VCC minus this R, that is 300 kilo ohm into IB minus, we need to consider the second terminal. VCC minus second terminal is minus 300 kilo ohm into IB. So R into I, that is nothing but voltage, minus this voltage is nothing but VBE. The second terminal is minus, so this is minus VBE, that is equal to 0. Now in this case the VB is not given, so we are going to ignore it. So what we are getting, VCC is 9 volt minus 300 K into IB. We are going to ignore VB, which is equal to 0. So after solving, what we are getting, IB is equals to 30 micro ampere. So this is all about the solution of IB. So IB, what we are getting, 30 micro ampere. Beta is given, so from this value we can find IC. So IC is nothing but beta IB. So we know the value of beta, that is 50, which is equal to 50 into IB is 30 micro ampere. So what we are getting, IC is nothing but 1.5 milliampere after solving. So we are getting, first we apply KVL here to find IB. From IB and beta we have calculated IC. Now IC is calculated. The second term to find is VCE. So apply KVL here. Now to find VCE, we are applying KVL here. So let's start. So VCC, this is plus, this is minus, this is plus, this is minus. This is nothing but VCE. the voltage across the terminal collector and emitter. So VCC, second terminal is negative, so 2 into, so this is 2K into IC, that is collector current, minus second terminal is negative, VCE, which is equal to 0. Now taking VC to the opposite side, so what we are getting, VCE is equal to VCC minus 2K into, now we found the IC value, what is that, 1.5 milliampere. So after solving, so what we are getting, VCE is equal to 9 volt minus 2, this is K. So we are taking this is 2K into 1.5 milliampere current. So after solving with what we are getting, so which is equal to 6 volt. So after solving this equation, we are getting VC is equal to 6 volt. So initially we applied the KVL here, we ignored the VBE, then we found the value of IB. From the value of IB and beta, we have calculated IC. So we got the term IC, the value of current. So current through the collector terminal. And then we applied the KVL here to find out VCE. By putting the value of IC, what we are getting, VC is equal to 6 volt. Thank you.